plastic. We use it in everything from packaging to products to technology. While it's a useful resource, most of it just ends up in a landfill, and of that, 8 million tons of plastic waste enter the oceans every year. And I can't do anything about that. But maybe with just a little bit of creativity, I can make a 3D printed boat that anybody could print out and use it to skim plastic out of their water all over the world. So that's exactly what I'm going to do in this video. Stick around as I design, print, assemble, and test out my 3D printed boat. So the story begins back in June when I got a 3D printer for my birthday. I didn't know a ton about 3D design, though I do use SketchUp a bit, and I don't know anything about 3D printing. I had this idea to make an RC boat that could pick up garbage in the water for a while now. I just wasn't sure how I was going to make it. But 3D printed seemed like the perfect option because people that live in areas that could actually use this thing can print it out themselves as a project. I thought I should probably walk before I run, so the first thing I actually designed and then printed were these 18650 battery cell holders. This is from when I was doing the battery pack build. The next thing I printed was a very simply designed part for a multi-part boat hull, and right after that I just dove in and started designing what I thought would work. By this time, it's probably about mid-July, and this design process lasted a while, mainly because I don't know how to design. So here's a nice time-lapse of the design to some funky music, instead of me explaining every little design choice, because I'll do that more when I'm putting it together. I tried to keep everything as modular as possible, kind of like a big set of Legos, since there is quite a few pieces I'm going to have to print. This flexibility also allowed me to design a bunch of parts later on, so I didn't have to have the whole thing designed before I started printing, because I could just plug in pieces later. As for 3D printing basics, I'm using PLA Plus filament with a layer height of 0.3 millimeters. I'll put all my slicer settings in the plans I'm going to release in a week or two. I also get it's kind of ironic that I'm making a thing out of plastic that picks plastic out of the water, but I really believe the only solution to a lot of problems is better technology and more creativity, instead of limiting people on what they can and can't do. So maybe this project will be one little baby step in someone else's journey to tackling big picture problems in the future. Like the rest of this project, I also don't know anything about RC, and I've never built anything RC before. But luckily for me, there's lots of YouTube channels that go really in depth. For a controller, I'm using the FlySky FSi6X and the receiver that comes with it. This is just the one I could find the most information on for programming the functionality I need. It looks daunting, but we're literally going to use one stick on this controller. So starting off basic, our controller or transmitter is what's going to send signal to the receiver that'll be inside the boat. Connected to this receiver is going to be an ESC or an electronic speed controller, and connected to that will be a motor and the battery. So first we're going to take our ESC and I'm going to plug that into channel 2 on our receiver. Then from our ESC we're going to take the 3 motor plugs and plug in our motor. This is going to be a dual engine RC boat since it's basically 2 pontoons that are completely separate from each other. So to connect the second ESC, I'm going to use one of these servo extension cables and plug it into channel 5 on the receiver. Before I plugged it in, I also took the end of the cable and snipped the red wire and then covered it up with some electrical tape. The ESCs provide power to the receiver, and since the one ESC is already doing that, I don't want to overload it with power from the second ESC. Then I'm just plugging in the motor onto the second ESC. Then plugging in identical batteries into both ESCs. And that's the full setup. Everything's pretty plug and play with RC, a lot more than I thought it'd be. Now we can turn on the controller and then turn on both ESCs and see what we have for power. I want everything to be controlled by this one stick so that I can do all the forward, backwards, and side to side all with one control. So if I push this stick forward or backwards, only motor 1 will move, and that's because it's plugged into channel 2 on the receiver, which is what this stick is controlling right now. So I'm gonna have to do a little bit of easy controller programming to get everything running how I want it. So I'm gonna hold down OK on the controller, and then use the down arrow to go over to the functions menu. Then I'm gonna scroll down to mixes and hit OK. So then I'll use the OK button to go down, and then I'll use the down button to turn this mix on. I'm gonna set the master to channel 2 and the slave to channel 5. And the positive mix to 100%, and the negative mix to 100%. Then for the offset, you're gonna have to play around with this a little bit for your specific setup, but mine was about -45. This just controls the difference for when both motors kick in, so you're just gonna have to play around with it till they both start at pretty much the same stick position. Then to save this mix, you have to press and hold the cancel button. So this mix is basically just telling motor 2 to start at the same time as motor 1. So if I turn everything on, the stick should start both motors at the same time. If one starts earlier in the stick than the other motor, then you're just gonna have to play around with your offset until they start at the same time. Now that's great for going forward and backwards, but we still have no side-to-side stick function. So to do that, we're gonna set up 2 more mixes. For mix 2, you want to just set it to exactly what I have here. And mix 3, do the same. I'm not going to explain this too much because, to be honest, I don't really know what this is doing. Other than the horizontal movement on the stick is channel 1, and that channel 1 is telling which of the motors to run when you move it side to side. But anyway, it works, so thank you other YouTubers. Then if I turn everything back on, the side-to-side motion seems to be working how it's supposed to. A couple other functions I did was in the system menu, I went to RX setup and then failsafe. And then for channel 2 and channel 5, I turned the failsafe on at 0% throttle. That way if the boat loses signal with the controller, the motors will shut off and not just keep on rowing out straight into the abyss. Lastly, I want to set up this switch to be a sport mode and regular mode. I only want to have about half the power available while I'm using the net to collect garbage, so that there's not too much stress on anything. But I also want a sport mode where I can use all of the power and just use it as a regular RC boat. So first in the system menu, I went all the way to the bottom to aux switches and I'm turning on switch D. Then in the functions menu, I'm going down to assign switches. And under fly mode, turning that to switch D. Then you can see if I flip the switch up and down, it flips between normal and sport mode. Then after I save that, I'm going up to dual rates in Expo. And with the switch in normal position, I'm going to switch channel 1 rate down to 50% and channel 2 rate down to 50%. That means when the switch is in normal position, only 50% of the motor's power is going to be available, but if I flip to sport mode, 100% is available. And here's a pretty good look at the 50% power in normal mode and 100% in sport mode.
After pretty well 2 weeks straight of 3D printing, my body is finally ready to assemble. So starting with the motor mount, first I'm going to cut out the supports I had to print in to support these pegs. Then I took one of these water cooling motor jackets and I'm going to slip it over top of our motor. Then I'm screwing the motor into place using some M3 bolts. Then I'm going to pop the motor into place like a big piece of Lego. Then I got these 15 centimeter length waterproof prop shafts off of AliExpress. And I'm going to connect the prop shaft to the motor using this pivoting connector. Since this can allow a slight amount of bend, there should be a lot less stress on the motor if it's not in perfect alignment, which it won't be. Next, I'm taking the ESC and putting a little bit of Velcro tape on the back, and then I'm just going to mount this right underneath the lid up beside the motor. And connecting in the motor wires. Next, I'm taking some 1/8 inch silicone tubing, and I'm going to connect one end to the water intake on the hull of the boat, and the other end to the motor cooling shroud. Then I took one more piece of tube and connected to the output of the cooling shroud, and this is going to connect in on the inside of our second piece of hull as the water output. Then I'm using some regular aquarium grade silicone and I'm going to seal the two pieces together. They're already a pretty solid structural fit just in the way they're designed with the pins, and the silicone is going to keep the water out and also prevent the two pieces from pulling apart. Then I'm doing the same with the front piece of the hull. And the other side goes together the exact same way. Now I've got 4 of these cross arms and I'm going to have to cut off the printing skirt. Then I applied some silicone to the inserted portion and fit each piece into the hull. Then I put some more silicone on this joining dowel, and I'm going to connect the two pieces together and bolt them in with some 1/4 inch bolts. Then I have this 2-piece cover I printed up, basically to just cover up the seam on that arm. And the Mach 18 just comes from that this was the 18th working file of SketchUp I had of this design. The back arm is pretty much the same, except for I'm going to have to run a couple of those servo extension wires through the arm before I install them. Then I can install the receiver, so I just plug the 2 cords that we had plugged in before into channel 2 and channel 5, and then use some Velcro tape to stick it inside the hull. Then I use some silicone to seal in the prop shaft on both the inside and the outside. Take your time and really work it into all the cracks here because this is the most likely part to leak on the boat. These hull covers just slide right into place. One cool thing I designed into this is this little groove. So basically when the water comes up and hits this cover, anything that leaks in underneath the overlap should theoretically drip down into this little trough that runs the whole way around it, and then ideally leak out the back and not into the electronics compartment. Though everything says it's waterproof, so a tiny bit of water shouldn't affect it any. Next I have these 1-inch screws, and I just heated them up for about 5 seconds before screwing in the arms to the hull. The heat helps the screws slice their own threads into the cold plastic. These little caps pop onto the back of the hull, and then I'm going to screw them in place using the same method as before. And then I have these 2 slots I can mount a skimmer net to ultimately pick up some plastic. So I printed up these brackets that are going to clamp around the frame of our net, and then they'll slide right into those slots and you'll be able to easily add the net or remove it without taking out any screws. As for our net, I got this cheap fishing net at Dollarama. It is a diameter of 14 inches, which means our net mouth opening is about 44 inches. So I took the netting off of the frame, and then I have this 3/8 inch aluminum rod that I'm going to bend to fit the shape of our boat. But first I'm going to cut this rod to 44 inches because I know that's how big the opening of our net is. And then we need our net to be about a 12-inch wide rectangle. So from the center point, I'm measuring 6 inches on each side to give us a 12-inch width. And then I'm going to have 6 inches on each end to make up the width at the top. And the remaining 9 or 10 inches between these marks will make up the height of our rectangle. Then I clamped it into place at each bend mark, heated it up with a torch for about 30 seconds, and then hammered each bend mark into a 90-degree angle until I had a rectangle. And now to join the 2 ends, I'm using this 7/16 inch threaded coupler. And I'm drilling in 2 holes, and then using an M4 tap bit to drill in some threads. Then I can work the net onto the frame. Slide that coupler onto both ends, and then use an M4 bolt to clamp down on both ends of the aluminum. Then I'm taking our 2-piece clamp and clamping it around the frame, and then heating up a couple screws to lock it in place again. And that's the last piece of this RC trash sweeping boat complete. Now, let's see if it floats. After the first couple minutes of running it with no net, everything is really dry inside, so I decided to install the net and see if I could find any garbage. This is a pretty clean lake, but it is Labor Day weekend, so who knows what we might find. After driving the boat around in circles for about 20 minutes, we finally spotted a water bottle about 50 meters out from the dock, so I had to go scoop that up. About 15 minutes later, we found a good-sized piece of bubble wrap. I was using a GoPro as a monitor to my phone for when I was getting out further, but a more reliable long-range connection, something like what's on a drone, would be a good improvement for the next version. After one set of batteries, or about 45 minutes on the water, our big cleanup haul was 3 items. But regardless, this proves the concept of this boat, and I'm gonna fix up a couple of things and come back in the morning. So last night, the only change I ended up making was I printed this little shroud that's going to go over top of our water intake hole and hopefully direct more water into the cooling tubes. So I attached this with some 2-part epoxy. I think it's just because of the low speed I'm driving, but the tubes don't seem to be sucking up water quite as efficiently as I'd like them to. Now everything seems to be keeping cool pretty well. The main problem with this build seems to be that I can't find any trash. I think it's pretty obvious I'm gonna have to go somewhere else after burning through a whole battery and not seeing anything, but I had to throw a couple cans in just to pick them up for my own satisfaction. One other problem that could be easily solved is I think I put on too short of prop shafts. Mine were 15 centimeters, and I think if you put on 30 centimeters and they extended out past the hull further, it wouldn't suck up air like this when you do anything over about 1/3 of a throttle. Then the boat should be a lot of fun just to rip around in sport mode, because it's losing most of its power to this. But that's going to be another modification that'll have to wait for the next video. So for a hopefully better hope of finding garbage, I went to a river about 10 minutes downstream of Kitchener-Waterloo. My thinking is that any litter from the city will probably wash out downstream. And there was a little bit more here, but pretty much all of it was locked into the sides, either stuck in some algae or right up on shore. Nevertheless, I was still determined to pick up some garbage. After driving aimlessly for a while, I spotted a risky rescue right near some algae. If I got the props clogged up, I knew I was probably gonna have to get in that water. Luckily, I rescued the package and didn't have to strip down to my package in this video. The catch was a plastic tub of worms, probably less than 8 hours old from some fishermen this morning. I did collect a couple more pieces over the next couple hours, but really wasn't worth it for where I was. But I know there's places in the world where this would be useful. So now I'm asking you, if you know a marina or a river somewhere in Canada, the US preferably, that this thing could be useful, leave a comment or send me a message with a photo to my Instagram at TrueBuildStuff, and who knows, maybe for the follow-up modifications video, I'll take it there and see how much garbage I can actually remove in a day. Till then, I know exactly how to make this thing useful. Now, I'm not kidding, that is actually a very practical way to skim a pool. So thanks so much for watching this video, and if you liked it, please consider subscribing so you can see what I get up to next. Like I said before, this is far from a perfect solution, but it was a lot of fun, and hopefully somebody else can see this video and use this as one small building block in their journey to solving issues in the future. And if you want to build this at home, I'm going to be putting the plans in the description below in the next week or so.